Welcome students to the session on operations research. In this session, we will be again discussing about the critical path analysis using critical path method where a dummy activity is involved. Let us take a problem now. The problem given is a project consists of following activities with the given data. Find the project completion time capital TE. Given that activities A and B can start at the beginning of the project. When A is completed, C and D can start. E can start only when B and D are finished. F can start when B, C and D are completed and is the final activity. G can start when E is finished and is the final activity. Draw the network, find the critical path and the project completion time. And the activities are given here. You can see A, B, C, D, E, F, G. This consists of 7 activities. The duration in time or duration in days. Activity A, the expected time of completion of A is 6 days, B 8, C 3 and so on. The precedence relationship is given here. So first we have to now we can construct a table with the activity, the precedence relationships and the durations so that we can draw the network diagram. So the precedence relationship is given here. You can see A and B do not have any preceding activities because they are the start activities. C can start only if A is complete. D can start only when A is complete. Similarly, E can start only when activities B and D are complete. F can start only when B, C, D, all these three B, C, D are completed. And similarly, G can start only when E is complete. These are the respective times, expected time of completion of the individual activities. Now, based on the relationships given here, when we draw the network diagram, we can see that this F condition of BCD preceding activity F, when we have to draw in the network diagram, only by the introduction of a dummy arrow we can satisfy this particular condition. So this dummy arrow here is not an actual activity but is introduced into the problem just to give you the precedence relationship. Consider the network. Now once D is completed, once D is complete, this F activity F can start only if C is also complete, and at the same time B also is a preceding activity to F. So F is dependent on 3 activities B, C and D. B, C and D for it to start. So F can start only when B, C and D are completed. So if I have to show all these 3 precedence relationships in the network, there has to be a network, there has to be a dummy activity added to this particular network, and this dummy activity will have a time of 0. Dummy activity will take a time of 0 because it's not a actual activity at all. It is just introduced into the problem and is represented by a dotted arrow. All the solid arrows represent actual activities, whereas this dotted arrow represents a dummy activity. So this dummy activity is introduced now so that all the precedence relationships are satisfied. And how you read a particular network, that is already explained in the previous video. This is a representation. This particular network diagram is a representation of the condition given in the table. So finding out the different paths now from start to finish, we see that the first path is 1, 2, 4, 6 with the day of 19. That's the total expected completion of 19. That is 6 plus 3, 9, 9 plus 10, 19, 19 days. The second path is 1, 2, 3, 4, 6, that is including the dummy. 1, 2, 3, 4 and 6. So that is AD dummy F. That again comes to 20 days. And similarly, you traced all the paths now from start to finish. All this from start to finish. So how this paths are traced, again refer back to the previous video in which this has been explained. So based on the different paths, we have now identified 1, 2, 3, 4, 5, 5 different paths. 5 different paths from start to finish. First is A, C, F. Second is A, D, dummy, F. Third one is A, D, E, G. Then B, dummy, F, B, E, G. So when you add all the individual activity times here, the maximum comes to this path. 1, 2, maximum time corresponds to the path 1, 2, 3, 4, 6 or A, D, dummy, F. So hence it's the maximum here. This is the minimum time required to complete the project. So the maximum amongst these paths is the minimum time required to complete the project. Hence it is the critical path. So all activities coming in this particular path are critical activities, and the total expected time of completion is 6 plus 4, 10, 10 plus 0 plus 10, 20, 20 days. You can see here, so this particular, this will be your critical activity here. This will be your critical activities. This will be activity A, the critical activity, because that is falling in the critical path. D will be a critical activity. Again, dummy activity. Please note, even dummy activities, even though they are not actual activities, dummy activities can be a part of the critical path. So AD dummy F will be critical activities. So activity A, activity D, the dummy activity, and activity F will be the critical activities. So here you can see, similarly as we have done in our previous video, earliest start of every activity will be equal to the earliest start of the preceding activity plus the preceding activity time. Since A and B have no preceding activities, earliest start of A will be 0, of B will also be 0. Earliest start of C will be the earliest start of A plus activity A duration time, it is 0 plus 6, it is 6. Earliest start of D will be the earliest start of A plus activity A duration time, again 0 plus 6, which is 6. Earliest start of the dummy will be the highest of values of E0 plus 8, that is if you consider B, and 6 plus 4 if you consider D. So the highest of this is 10. Similarly, the earliest start of E will be the highest of the values of, say, B, that is 0 plus 8 will get if you consider B, and 6 plus 4 if you consider D. So highest of these two will be 10. Similarly, earliest start of F will be highest of the values of no, 6 plus 3, 6 plus 3, that is if you consider now C, and 10 plus 0 if you consider the dummy activity. So out of these two, highest is 10. The earliest start of G will be the earliest start of E plus activity E duration time. So 10 plus 6 is 60. And once you get the earliest start of, say, see now the earliest start of F is 10 and earliest start of G is 16. So once you add these earliest start times with the individual activity timings, if you consider F, the earliest start is 10, so 10 plus 10 is 20. If you consider G, the earliest start is 16, 16 plus 3 is 19. The highest of these two values is 20, so the expected time of completion of the project is 20 days. It is 20 days here, so the expected time is 20. Now similarly, if you now we calculate the latest start from finish to the start. If we start calculating the latest start now, 20 minus, if I consider G, 20 minus 3 will be 17. Similarly, 20 minus 10 will be 10. So latest start of G is 17, latest start of F is 10. Latest start of E will be the latest start of G minus activity E duration. So for E, when you calculate latest start, it will be 17 minus 6, it will be 11. Similarly, the latest start of dummy will be the latest start of F minus activity dummy duration, that is 10 minus 0, it is equal to 10. Latest start of C will be latest start of F minus activity C duration, 10 minus 3, 7. Latest start of D will be latest start of dummy minus activity T duration, 10 minus 4 is 6. Latest start of B will be latest start of dummy minus activity B duration, 10 minus 8, which is equal to 2. Latest start of A will be latest start of activity D minus activity A duration, which is 0. So when you calculate all this and find out for which activities the earliest start and latest start are equal. If I tabulate the same findings of ES and LS now in the form of a table, we will get this. You can see here the activities are given, earliest start times are given, the latest start times are also given here, and the slack for each activity is given. So wherever the slack is 0, those will be your, for whichever activity slack is 0, those will be your critical activities. Those will be your critical activities. So here A, D, dummy, F now become the critical activities with a slack of 0. A, activity D, the dummy activity, and F with a total expected time of 20 days. So this is your project completion, expected completion time of the project, that is T is equal to 20 days. Critical activities are A, D, dummy, and F. So this is similar to your previous problem which we discussed in the previous video, but only thing is a dummy is introduced here, and this dummy can also be a part of the critical part. Please keep in mind, a dummy activity can also be a part of the critical part. So all non-critical activities will have a particular slack. For example, if we take activity B, B has a slack of 2, which means there is a permissible limit of 2 days on activity B. So even if activity B is delayed by say 1 or 2 days, it will not cause say any changes in the project completion time of 20 days. Whereas for all critical activities, since the slack is 0, the earliest start and latest start are equal, and slack is 0, no delay is permissible in the critical activities. So in the next session, we will be taking a program evaluation and review technique, PERT technique. We'll see how PERT technique is applied to problems, networking problems. Already seen that CPM and PERT are different in several aspects. One major difference between CPM and PERT is in PERT we are using 3 time estimates instead of only 1 time estimate. So PERT is highly probabilistic in nature, so we are using 3 time estimates. So in our next video we will be discussing about the application of how we actually find out critical path for a PERT, for a PERT problem. That will be a topic for the next session. Thank you.